questions over any of the assignments that we've had thus far? All right, guys. The last thing we're covering in Chapter 8 over similarity are these properties, these proportionality properties. Now, the first one is the triangle proportionality theorem. If a line is parallel to one of the sides of a triangle intersecting the other two sides, then it divides the two sides proportionally. So if the two lines there are parallel, then it divides the triangle proportionally. That this length, well, it'll be good if I can actually write A, B, C, D. Well, we could say that A over B is equal to C over D. Those lengths are going to be proportional to each other because those two lines are parallel. Well, the converse is saying that, well, A, B, C, D, if A over B is equal to C over D, then these two lines are going to be parallel. And this here's the main first theorem that we're looking at. So, and we're just using it to solve. Now, the way we're solving these here aren't any different than what we did yesterday or the day before when we were talking about proportionalities. It's just how the triangles are set up, or in this case, triangle 1. In the diagram, QS and UT are parallel. RS is 4, QU is 9, and ST is 6. What is the length of RQ? Well, if these are parallel, we do have a proportion, yes? And we want to find the length of X. And with any of these proportions, it's always nice or always easier to solve when X is in the numerator, not in the denominator. So for this here, we'll put X in the numerator. Now, what is X going to be over? 9. Because we're going to have this length over this length is equal to what? 4 over 6. They're corresponding parts of the triangle. Because we have the small over the bigger, or small over, so here, the top line segment over the bottom is equal to the top line segment over the bottom. And I was going to say big and small, but that's not necessarily the case. Because those parallel lines could be closer together, which would make the top section bigger and the bottom section smaller. But we just want them to be the corresponding parts. Now, what do we think we would do next? Multiply both sides by 9, which is essentially what we've been doing the last few days. And the reason we do that is because 9 times our 1/9 will simplify to 1. Because that's why we're multiplying it. Now, normally we just cross it out. But just as kind of a reminder, when we multiply this by 9, the reason they cancel out is because we're saying that we actually have 9x over 9. 9 divided by 9 is 1. So it just gives us x. So that's why we're able to just cross it out, because it simplifies to 1. Now on the other side, we have 4 over 6 times 9. Well, we can multiply 9 and 4, which would give us 36 divided by 6, which is, or we could have just plugged that into the calculator, hit enter, and been done. Any questions on this here? We good with this here? All right. So this one here, we want to find the length of ZY. So again, we have a triangle with 2 parallel lines, and we want to find the length of YZ. So how would we set this up? So X, I would put X first. So X, yes. And then, what would go on the bottom?
I don't know. Some 36. 35 less than
44 over 35, and I think y'all are all agreeing with 36 here, yes? Those both work. Now, let's see here, if it'll let me grab, okay, I'm going to have to select this and tell them to group, ungroup. All right. Yeah. Group those. Group those. Now, because I think this is what you were wanting to set up, yes? These are the same, because they're still equal to each other, yes? But the big thing in how we set these up, because no matter how we arrange these two fractions, we need the x and 36 to be together, because those two are proportional. We need the 44 and 35 together because those two lengths are proportional. As long as we have the proportional part set up correctly, the side of the equal sign that we put them doesn't really matter. So either way, having the 44 over 35 first or the x over 36 first, either one's fine. Because again, we're still going to multiply both sides by. Apparently, I'm just going to erase 36. And we don't quite have this set up correctly. And the reason I say that is because if we look at this here, x is this length, yes? What side corresponds to it? The 35 should be on, and the 44 should be on bottom. Now, as we saw in the last one, these will simplify to 1. And now we need to multiply 35 over 44 by 36. 2, 18. Because I feel like that should give us a whole number, but what do we get? X over 36 is equal to 35 over 44. And that there would be our answer. 35 over 44 reduces to 35 over 44. Yep. Yep, so in this one here, we don't get a nice answer, but that doesn't matter, because as long as they're still proportional, we get this here. Questions on any of this here? All right. Let's look at one last one, and then we will move on to the next type. So they gave us the diagram with two parallel lines, and we want to know what the length of VW is. And again, we're going to have two fractions. Now, how are we going to set these up? Is equal to? Yes. And then what do we do next? Times both sides by 12. So here the 12 and 12 will cancel, telling us x is equal to. This will give us a nice number. Oh. And that's all we have to do for this here. Any questions on any of this here? Any questions on everything we've done so far? Okay. So now we're using the converse. Because we do have two triangles, one on either side of the foot shelf or foot rack. shoe rack. Shoe rack. Now, what they want to know is the shelf itself, so our line segment BD, is it parallel to the floor? That's what we want to know. That's what we want to find out. Now they tell us that BA is 33. They also tell us that CB is 27, CD is 44, and DE is 25. Now, if these segments are proportional to each other, then we can say that line segment BD is parallel to line segment AE. So what we're looking at is what? What over what? Over? Okay. And what would the other fraction be? 25 over 44. Now at this point here, we would want to try to simplify these in a calculator to see what they are so we can compare the two. Because this one here would be 11 over 9. 25 over 44, I think it's 25 over 44. So do these reduce to the same? No, they're not the same. They're not proportional, are they? So can we say that these two, that the shelf is parallel to the floor? No. Side lengths are not proportional. They're not proportional. Because if the side lengths were proportional, then we could say that it's parallel. But here the side lengths are not proportional. Questions on this here? Okay. All right, so we're going to do this again. But this time, they tell us that BA is 35. CB is 25. CD is 20, and DE is 28. Wait a minute, I'm going to look back at this. So when we talked about proportionality, we always said it kind of matched up, yes? Biggest with biggest, smallest with smallest, yes? Because if we're talking about proportionality, they're going to stay the same. One's not going to magically get smaller when we go for the other. If it's bigger on the first, it can't just magically become the smaller, yes? 33 and 27, which one's bigger? 33, yes? Over here, 44 and 25, which one's bigger? 44, yes? Wait, did I just flip? So is there a chance that these were not going to be proportional? Well, yeah, because no matter how we set that up, they're not in the same setup. Because looking at this here, 33 over 27, bigger number over smaller. The other proportion is smaller over, there's no way these are going to be the same. Okay, maybe we can use that on this one. 25 and 33, smaller over bigger. Is that the same kind of setup on the other one? Well, yeah, because 20 is smaller than 28. Does that guarantee that they're going to be proportional? But it does give us a better likelihood, yes? So now we just need to see how they compare. So we're looking at 25 over 35. And our other one is 20 over 28. Now we just need to reduce these here, and if they reduce to the same fraction, then they work. move him over. 25 and 35 are both divisible by 5, which would give us 5 over, okay. 20 and 28, 4. So are they parallel? Yes. Because the side lengths are proportional. Bless you. The side lengths are proportional. And this here is really just using our converse theorem. Any questions on this here? All right. The next one that we have is the 3 parallel line theorem. If 3 parallel lines intersect 2 transversals, 2 other lines, then they divide the transversals proportionally. So we can call this A, B, C, D. So they divide them proportionally so that they divide evenly. Okay. I was thinking there's something right there. But really we're saying that A over B is going to equal C over D. Those parts are going to be proportional. Even though we're not talking about a triangle, it's going to divide them proportionally. Questions on this here? So, if we look at this here, in the diagram, angle 1, 2, and 3 are congruent. GF is 120, DE is 150, and CD is 300. Find the distance between H and G. Well, the reason they told us is that those 3 angles are congruent is to tell us that these 3 streets are parallel. And the reason we're able to say that is our corresponding angle converse. Corresponding angle converse. Because the corresponding angle theorem states if 2 lines are cut by a transversal, then the corresponding angles are congruent. Corresponding angle converse. If 2 corresponding angles are congruent, then the 2 lines are parallel. Because 1, 2, and 3 are all on the same side of the transversal and on the same side of each line. So we can say that these 3 lines are congruent. Which means we can go back to our proportionalities that we've been using. And we can say x over what? So we can say 120 is equal to almost 300 over, because we used the length from G to H. Its corresponding side that's a part of it is from C to D, which would be our 300. And then we would have 150 on bottom. At this point here, we can multiply both sides by 120. And here the 120 and 120 will cancel out. And now we just need to multiply 300 over 150 by 120. Give us 60. I think it needs to be bigger. 240. Yeah. And I say that for 2 reasons. One, if we look at the fraction 300 over 150, the numerator is bigger than the denominator, yes? So whatever number we get when multiplying it by 120 should go up. Also, if we look at the figure, because 120 is on top, 150 is on top, yes? 150 is comparing with 300. 300 is bigger, yes? So the length for G to H should be bigger than 120. So we're expecting it to get bigger. Those are two reasons. Now, what is 300 divided by 150? So 2 times 120 is? So looking back at the original problem is somewhat helpful to make sure, did we get it right? Does it fit in what we're looking at? And that's all we have to do for this here. Any questions on any of this here? Let's look at the next one. So again, these lines are parallel. And we're looking for EF. Okay, well, we can put X on top. Now, what do we expect the value for EF, that X, to compare to 35? Smaller or bigger? Smaller, because our other sides are 30 and 12, yes? The 12 is corresponding with our X, are kind of on the same, between the same set of lines. So we should expect it to be less than 35. So X is going to be over what? X over 35 is going to equal? Now again, we're going to multiply both sides by 35. And we do this because the 35 and 35 will simplify to 1. And on the other side, we have to multiply 12 over 30 by 35. Seven. I think we should get 14. Well, the reason I say that is because 35 and 30 have a common factor of 5, yes? That'll reduce 35 to 7 and reduces 30 to 6, yes? What's 12 divided by 6? 2, yes? 2 times 7 is 14. But again, all we got to do is type that in, and the calculator will do it. Any questions on any of this here? We ready for the next one? All right. We'll find line segment JM. So how would we set this up? Is equal to? Too many numbers. What? Because here we're going X and 16, yes? Now the sides that match up with X is our 18. Now again, from 15 to 18, is it going smaller or bigger? Going bigger to smaller, smaller to bigger? Because 15 is smaller or bigger? Smaller, and we go to a bigger number, yes? So here, we're expecting X to be, what, to compare to 16? Bigger, because 15 to 18 is getting bigger, so 16 to whatever X is should be getting bigger, yes? Anytime we deal with something getting bigger, the scale factor should be greater than 1. And really, our 18 over 15 is kind of a scale factor. Because what we're going to do is we're going to multiply both sides by 16. Well, the 16 and 16 would cancel out. Minus X is equal to 18 over 15 times 16. 96 over 5. Convert it to a decimal. So it's 96 over 5. I think if you hit the 2 arrows, does it give you 19.2? Yep, I would take either one. I would take either one of these here. Because since they are the same answer, they have the exact same value, they're both correct. Any questions over any of this here? All right. I think we feel comfortable with these, yes? And the correct answer for this, I believe, should be 12. Let's go on and look at the last one, triangle angle bisector, the triangle angle bisector. If a ray bisects an angle of a triangle, cuts it in half, then it divides the opposite side into segments whose lengths are proportional to the lengths of the two other sides. So we're looking at AD over BD. You can say X over Y is equal to W over, so AD over BD, AD over BD, X over Y is equal to CA W over Z. This side over this side is equal to this length over this length. So the two parts that are split are going to be over each other, and then their corresponding sides are over each other. Almost like this triangle here, this length over on top, so W's on top, Y's on bottom, Z's on bottom, or vice versa. Let's look at an example to see this here. So we have a triangle whose angle is bisected. Okay, well, not trying to underline that word. So we'll have our two fractions, and again, we'll want to put X in the numerator. Now, the other part, because these go together, so X is going to be over 13, is equal to this segment over this segment. Now, what's the segment's length in red? Well, we don't know, do we? But I do know what the whole length is. It is 15. Yes, because the other segment is 9.75. So what we can do is say 15 minus 9. Because we would put 0, 0, 4, 9, 10 would give us 5, 2, 14 would be almost. Because the 0.25 would take us from 9.75 to 10, and then we need 5. So our other segment is 5.25. Now what do we need to do next? Both sides by 13. Because here the 13 and 13 would cancel. Which tells us on the other side we just have to plug in 5.25 over 9.75 and then multiply by 13. That looks right. Almost. Actually, I think it should be 7. Let me see. Yep, try it again. Let's see. There we go. You get the same thing, Dylan? Dylan. Yeah. Questions on this here? All right, let's do another one. I don't think we have too many more of these here. So we need to set this up. How would we set this one up? Yes, because the two side lengths that are cut, the side length that's cut in half, those will be over the top of each other. And again, it's nice to put y or the variable on top. Now what are we going to do for the other side? Yes. Because the line that connects to y is our 63. Since y was on top, it would be on top as well. Now the other side is 42. Now what do we need to do next? Times both sides by 18. And here 18 and 18 will cancel, giving us y by itself. And we get y is 27. Any other questions on any of these here? So we'll do this one and the next one, and the next one's actually even easier. So what do we do first? Yes, x over 14 is equal to? Yes. And then both sides by 14. Yes. We could, because 48 over 24 is 2, yes? So our x is equal to, well, we could say 2 times 14, so x is 28. Because when we compare 24 to 48, we're just multiplying by 2, so 14 can be multiplied by 2 as well. Because that 2 is just our scale factor. When we're comparing the other sides, we're just finding the scale. Any other questions on this here? If you were to guess what the value of the variable is, what would you all say? Almost 4 squared to 2, yes? Because again, one of the fractions is going to be comparing these two to each other, yes? So on one side, we're saying 4 divided by 4, which is 1. Our other side is going to be what? Y over most likely, because since our proportionality, our scale is 1, because when we multiply both sides by 4 square root of 2, these will cancel, telling us y is, yeah, this one instantly worked out. We actually didn't really need to solve anything if we noticed that the scale was 1. Any other questions on this here? And out of all these here, we actually can say that these two angles are both 45. And the hypotenuse, or the angle that's bisected, 90. Because when we set this up, well, if you remember back to our special right triangles, sides opposite 45 degrees are the same, and the hypotenuse is going to be whatever that length is times square root of 2. Because 4 plus 4 is 8. But this one here is not on the note sheet, and I forgot about him. And this is one I do want to look at. Now, we are going to need to solve for x, yes? We do have two side lengths that are already given to us. I'm going to put 13 on top over 7, because 13 does connect to the side with x, yes? Now, do we know what the length from S to R is? Yes, it's what? X, yes? So I can say that that is X. What's the length from Q to R? We don't know. But we did have one similar to this earlier, yes? Because they gave us like the bottom length is 9.75 and the whole length was 15. So to find the other part, we took 15 and minused it, yes? Almost. 15 is how we would have to set this one up because we don't know what that or the other length is. So we can subtract x from it. Now, here, I have variables in the denominator of 1, 15 minus x, yes? This one here, we're going to have to use cross multiplication or least common multiple, least common denominator to solve. Because we can multiply both sides by 7. And if we do that here, the 7 and 7 would cancel out, yes? But in the other fraction, I still have the 15 minus x, yes? So I'm going to also have to multiply both sides by 15 minus x. Because here, the 15 minus x and 15 minus x would cancel. Now, what that leaves us with is on the left-hand side, we have 7 times x, which is equal to times 15 minus x. Now, in Algebra 1, I believe in 8th grade math, they talked about cross-multiplying. We multiplied the two denominators by the opposite numerators. Or the butterfly method. And that's what we did. But at this point here, we just need to finish solving. We need to distribute the 13. So 13 times 15 is 195. Stop scrolling. Minus 13x. Well, the next thing we would need to do is to add 13x to both sides, which will tell us that 20x is equal to 195 by 20. And then we get that x is 5.25. No, I'm just guessing. 9.75. Which actually does make the other length 5.25. Which this is the problem we solved earlier. But this time we solved it where we didn't know that that one length is 9.75. Because if you remember back, we did get that the answer was 7. And that's it. Questions on this here? Was this any real harder than what we did previously? Well, no, once we got past or kind of saw that trick to it, x minus 15 and multiplication, it's the same thing as what we've been doing. And incidentally, that is the end of Chapter 8. That is the last part of Chapter 8. Now, I do need to update the sideboard because we are going to have a scavenger hunt like we did on the previous. We've done it twice. This one's going to be a little bit different because when I set it up, I put the answers on bottom and the questions on top. So you're just going the other direction because all the other ones, the answers were on top. The next clue was on the bottom. So they're just flipped. That's the only real difference. Everything else is going to be the same.